we go to the fact of what we call hydrocarbons. Hydro comes from hydrogen, carbons. So these are compounds with just hydrogen and carbon. So methane has got just hydrogen and carbon. So do you think methane's a hydrocarbon? Yes. And so what we've done in this column here, now we've got a group that are just hydrogen and carbon. And we call those the alkanes. Now don't write anything yet. We asked you to remember a little rhyme. The first just hydrogen and carbon is called methane. Now would anyone here think that they've remembered what the next one is in that rhyme?
Ethane.
Ethane. Do you know the whole rhyme?
Not, I think so.
Do you want to come up here and just give it a go? We salute all bravery. Okay, just give it a go, the rhyme we asked you to learn for home.
Methane, ethane, propane, butane, heptane, hexane, octane, it is one missing. Pentane.
Okay, but great. You see, if you've got the first four. So that is great, because those are the ones that don't really make logical sense. So,
What do you mean, sir?
because, so you got the most important ones. We can work out the ones after four, because so it goes methane, ethane, propane, butane. I'm just going to tilt this way. We can work out the next. What do we call a figure that has got 5 sides? We call it a pentagon. So then we get 5 carbons equals pentane. What do we call something with 6 sides? A hexagon. So we get hexane. Now, you wouldn't really know, and it's quite hard, I don't even really know how to draw 7-sided. It's called heptane. So 6 carbon, 7 carbon is HEP, T-A-N-E. I presume hept is Latin or Greek for 7. And then we all know an octopus has got how many legs? 8. So 8 carbon octane. And then it goes actually nonane and decane. We could easily remember how I grab a sheet. So let's all do it slowly together. Methane, ethane, propane, butane, pentane, hexane, heptane, octane. And those are the ones they're going to ask you. Let's do it a bit faster. And can I ask you to, however you count, because I want you to do it with your fingers too, like you were counting on your fingers. Okay, so are we ready? We'll go just a little bit faster. Methane, ethane, propane, butane, pentane, hexane, heptane, octane. A little faster. Methane, ethane, propane, butane, pentane, hexane, heptane, octane. Real fast now. Methane, ethane, propane, butane, pentane, hexane, heptane, octane. Give yourself a clap. Okay, so we've left space in that column for you to draw all of them. So if you're going to be drawing them, then you've got to draw a carbon joined to a carbon. That is your backbone. Okay, you draw your carbons first. You check that each carbon has got 4 bonds. 4 bonds. You fill what's left with hydrogens, and that would be ethane. Then you do the same with the next one, propane, which has got 3, butane, and hexane, heptane, octane. Okay, all happy with that? I want to do a little bit more before I let you go and get busy filling in your sheets. I'm giving you chemistry, organic chemistry 101, 201, and 301 in one go, because I know you can cope with it. Happy? Should we give it a go? Are you up to speed so far? No problem. Okay, let's get on to our favorite organic compound, alcohols. Okay? Now, how do alcohols differ from the alkanes? So we got now the alcohols. Now watch this. Alcohols have now got an oxygen. So what we're going to do is, if we're going to stop, let's take we know methane easily. Everyone have no problem with methane. So we draw methane, 1, 2, 3, 4, hydrogen, 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 hydrogen. Now we add an oxygen. But oxygen has got 2 hooks. Remember that? There's 1 hook left over and we add the hydrogen. And that is now not methane, but methanol. So all the anes ended in ane. Methane, methane, propane, butane, pentane, hexane, heptane, octane. They all ended in ane. Now let's try the same with the alcohols. Woo. Methanol, ethanol, propanol, butanol, pentanol, hexanol, heptanol, octanol, and they all have got an OH group. We call that its functional group. All the alcohols belong to the same family. The whole family doesn't make you drunk. Some make you blind, like methanol. Only ethanol makes you aggressive, sleepy, whatever you become when you don't know yet. We hope. I just get sleepy, so I don't bother anymore. Okay. So, but all the other alcohols don't. It's only ethanol that is supposed to make us happy. Okay. Ethical question. Let's stop there. Now, for your prac tomorrow, you see I've got to speed through this. I've got to give you the next functional group as well. The next, they call them, the homologous series. The next homologous series or family of compounds is called the carboxylic acids. Now, I'm pushing it a little bit. So this was methanol. I know I'm pushing it a little bit, but I know you guys, you're good. And you're going to get even better all the time with your memory. But anyway, it's written down so you don't have to worry, and then you're going to write it down yourself. Okay, how many carbons do you think the carboxylic acids, the first one has? If this had 1 carbon, that had 1 carbon, this has got 1 carbon. Now here's what makes it an acid. Okay, watch this. It's also got oxygen. It's got 1 oxygen up there. It's got 1 oxygen there and an OH. So it's actually got that group there. By the way, I've just swapped it around because I've got to do something for the practical. And then count the bonds. Carbon's got 1, 2, a double bond, 3, so it needs 1 more, doesn't it? Doesn't matter where we draw it. What should we put there? Or what do we put if we've got nothing better to do? Hydrogen. So that is now called methanoic acid. Thank you for asking. Why is it a double bond? Okay, you haven't met double bonds yet because this is our first lesson on organic chemistry. Have you heard of double bonds ever? Yes. So what it is this is our oxygen. It's got a hook there and a hook there. We can take that oxygen and bend those hooks together. Does that make sense? Like they were a spring. So there's the oxygen with its 2 hooks taking up 2 of carbon's hooks. Then that leaves carbon with 2 more, and we add on that O and H there, and we have 1 left, and we make that a hydrogen. And they're all named as follows. They're all acids, right? So what do you know about acids? They like any properties of acids, you know? Do you like getting acid on you? No. Because it burns, right? The commonest acid in the home is like vinegar. Vinegar is an acid. You know, you put vinegar on your fish and chips. And it's slightly sour. Lemons contain acid. Citrus contains citric acid. All acids that you eat end in COOH. COOH. We call that its functional group. That's what makes it the family of acids. Now, I know I'm pushing you fast. Let's try and see if we can name the acids in order. They all end in oic acid. I know, let's try it. So we'll go slow. We start with methane, so we say methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, hexanoic acid, heptanoic acid, octanoic acid. I've still got to check which ones of those we've got, but let me tell you what your practice is going to be. Seeing as you're so expert now on all of this, let's tell you what we're going to do tomorrow. The reason I'm happy to throw you in at the deep end is it's a lovely, easy prac. Oh, you can't get an easier prac than this. It's easy to do, but the theory might be a little bit more complicated. What we're going to do tomorrow is we're going to join an alcohol with a carboxylic acid in a test tube here. And we're going to get a fourth family called the esters. So, what am I going to do? To divide you probably into groups of 4. Depends what we got. I'm going to give you a test tube of one alcohol. Methanol, ethanol, propanol, butanol, whichever we've got. One of them. Then I'm going to give you another test tube with carboxylic acid. Methanoic acid, ethanoic acid, propanoic acid, butanoic acid. One of them. Then you mix the two. Just a few drops of each. And now we're going to take them and put them in a little beaker of boiling water and leave them for 5 to 10 minutes. But we now need to catalyze the joining together to form an ester. So we add a few drops of sulfuric acid. Sulfuric acid is probably the one chemical I fear, because if you get that on you, you know that sometimes people throw sulfuric acid around, they get it in their eyes and it just chows you, just eats you. So it's something I really fear. They put it in batteries. Okay. So we just add a few little drops of sulfuric acid. You know what the sulfuric? Let me tell you what the sulfuric acid does. Sulfuric acid, if you get it on your skin, it pulls all the water out of your skin, which is the same as burning. So it's like a chemical burn. So look what this sulfuric acid does. It takes OH and H in the presence of H2SO4. Just look at that. It takes an H from the alcohol, an OH from the carboxylic acid. It sucks the water out of them and it joins that to that, and we get carbon, oxygen, hydrogen, hydrogen, hydrogen. Watch what I'm doing. There's your methanol. Lost its hydrogen, but it joins straight to the next carbon. You see the oxygen, carbon, oxygen, carbon. And then this carbon still got its O and its H there. Check the number of bonds. Carbon, 1, 2, 3, 4. Oxygen, 2. Carbon, 1, 2, 3, 4. Each hydrogen, 1. And this is now called an ester. Now, how do we name esters? We name it, I just want to see if this is getting that. Let's just turn it a little bit.
So,
Yeah.
do our esters slowly.
Sure. Thanks for asking, because so we do methyl, its name is this part, methyl. Wow, that went fast. All one word. That part is also, it was methanoic acid, methanoate. So it's methyl methanoate. So all esters go IL-OH. Methyl methanoate, ethyl ethanoate, propyl propanoate, butyl butanoate, and so on. It's a hell of a lot I've given you. I didn't realize the lesson's so far gone. I'm going to ask you, as you go out, I'm going to ask you for homework, if you wouldn't mind just trying to do as much of that sheet as possible. Fill in the alcohols, the acids, and see if you can possibly have a go at the esters. And if I could take your homework in. Thanks.